Hey guys, today we're going to review Unit 4, which was about systems of equations and inequalities. We are going to need a calculator here, so as you can see, I have one up and I'm going to be using it the entire time. Okay, so to start off with, how do we write a system of linear equations? So a system will always have two equations, and we're going to write them different ways. So if you're given tables, or if you're given a graph, the first thing that you want to do is pick 2 points. Then using those 2 points, calculate the slope. And then after you have slope and you have a point, you're going to use point slope form to write your equations. Okay. Now, if you're given a word problem, that's a little bit different. You're going to read the word problem and you're going to find the two variables and define them. Okay, after you have a variable for each of the things, you're going to use math keywords to write your equations. Okay, so I have an example of each. So the first example we're going to look at is a graph. So since this is a system, see how there's two lines? We need to find an equation for both lines. So let's start with K1. See how it's labeled? So let's look at K1. If I follow those directions, I need to pick 2 points. And just a heads up, if at all possible, try to pick your y-intercept. So on this one, y-intercept I can tell is at -2. So I'm going to write that as 0, -2. And we need another point. It has to be one of those perfect points that goes exactly through the corner. So I think right here should be good. That's the point 1, 1. Okay, so first thing we want to do is calculate our slope. So I'm just going to write K1 so I know I'm doing that one. So M equals the difference of the y's, so -2 minus 1, over the difference of the x's, 0 minus 1. So I'm not even going to try to do this in my head. I'm going to use my calculator. So the numerator, I'm going to put it in parentheses. And make sure you use different buttons for negative and for minus. Then divide to make it a fraction. Now parentheses around the bottom. 0 minus 1. Enter. And that's just 3. Okay, so I have M is my slope. And guess what? I also have B. Remember, y-intercept represents B. So I can write my equation already using y equals mx plus b. So our equation here is going to be y equals 3x minus 2. Okay, but I still have another line. So let's look at that other one. We're looking at K2 now. Same thing. I need 2 points. Y-intercept is always going to be the easiest thing to pick, so I can tell the y-intercept is at 0, 4. And we need one more point. So I'm just kind of like going through this here, trying to find a good point. And it really doesn't look like I get one till right here. So at -9, +8. So I'm going to use those 2 points to calculate the slope of K2. So difference of the y's, so let's do 4 minus 8 over the difference of the x's, 0 minus -9. If you want to, you can leave it like that, or you can change it to a plus sign when you have double negative. But let's just put this into the calculator and see what we get. So parentheses 4 minus 8 divided by parentheses 0 plus 9. And it gives me this long decimal. So just remember that slope is never a decimal, it's going to be a fraction. So how do I convert this to a fraction? Good thing is that the calculator can do it for you. So I want this number. So either you can retype it, so -0.0 or 0.44444, or let's delete that. Or you can put second and the negative sign, see how it says answer? So that just means your previous answer. Then press math, and that very first thing that shows up, frac, that means that it's going to turn it into a fraction for us. Enter. So that's just -4/9. Okay, but that y-intercept, remember that that's already b, and then my slope is m, so I can do the same thing, y equals mx plus b. So this would be y equals -4/9 x plus 4. And those two equations, that is what my system is. So you would look for an answer choice that has both of those equations. All right, so let's look at a table now. So 2 tables, I need to find an equation for each one. So let's start with the one that's labeled line Q. I need 2 points. So the good thing about tables is it's organized by points, x1, y1, x2, y2. And then that one would be x3, y3, but we don't need it, so I'm not going to write it. Okay, so let's start off by finding our slope. So difference of the y's, 18 minus 0, over difference of the x's, -3 minus -9, and we know that turns to a plus sign. So let's just put this into the calculator. Okay, so that is just plain 3. Okay, if you had a y-intercept, that's what you want to go for. Y-intercept is going to be where x equals 0, but if you look at our choices, we don't have x equals 0. So we're going to have to use point slope form. That's the one that looks like this. We're going to fill in the things that we already know. So we know what y1 is, we found out what m is, and we know what x1 is. So let's fill in those 3 spots. So we have y minus, and y1 is just that 0 there, equals m is this part, 3, x minus, then x1 is -9. So of course we're going to fix that part, minus negative is plus. But now let's simplify. -0, it just cancels out. And then this 3, we want to multiply it in. So this will leave us with y equals 3x plus 27. Now everything that we just did, we want to do it one more time for line V. So again, I'm going to label x1, y1, x2, y2. Let's find the slope. So difference of the difference of the y's, 8 minus 10, over difference of the x's, so 0 minus -4, that'll turn to a plus. So let's see what we get. Okay, so -0.5, I'm going to do second answer, math to fraction, and that's just -1/2. Okay, now we're going to use point slope form to find our equation. We have 3 spots to fill. So y minus, we labeled 10 as our y1, equals -1/2 x minus -4, but that's going to turn into a plus sign. Okay, so let's distribute the 1/2. That would give me y minus 10 is equal to -1/2 x minus 2. And then now we're going to move our 10 to the other side. So y is equal to -1/2 x plus 8. And those are my 2 equations that would make up my system. Okay, last is that word problem. And I promise the word problem is a lot easier than graphs or tables. So it says a drummer and a guitarist each wrote songs for their band. The guitarist wrote 8 fewer than twice the number of songs that the drummer wrote. They wrote a total of 46 songs. So first we define the 2 variables. So what are the 2 things that they're talking about? Well, it's drummer and guitarist. And you can use any letter that you want to represent each one. Like I know some people like to use X and Y, but I like to use the first letter. So I'm going to say D is guitarist, or I'm sorry, D is drummer, G is guitarist. Okay, so starting with right here, guitarist wrote 8 fewer than twice the number of songs that the drummer wrote. So anytime you do something twice, that means that you're multiplying by 2, so twice of the drummer. But then it says 8 fewer, so we need to subtract 8. Our second equation goes along with this part. They wrote a total of 46 songs. So all of the drummer songs, all of the guitar songs together makes 46. So all that is adding. Drummer plus guitarist equals 46. So those two equations are what's making up our system here. Okay, so now that we practice writing systems, let's look at how to solve these. The best and easiest way to solve is to graph. So the solution to a system of linear equations is the coordinate that makes both equations true. And there's 3 different types that will show up. So there's one solution, and this is the most common one, when the lines intersect. So it'll look like an X, and you're looking for the spot where they both cross. There is no solution when the lines are parallel. So that means that they would never cross. It would look like this. And then the last type is there are infinite solutions. When the lines overlap. So you would graph a line, and then you would do the other graph, and it would land right on top. That's infinitely many. So of course you can always graph by hand, and if you look at my examples, I do have a graph there so that we can draw them. But the cool thing is that we are always allowed a calculator, and the STAAR even has one built in. So these are the steps that you would use to work these out on the calculator. So I'm not going to do mine by hands. I'm going to do it all on the calculator. So let's see. I'm trying to get this to all show at the same time. All right, cool. So the first step is to rewrite the equations as y equals mx plus b. So this first equation, that one's already good to go. MB, right? But this second one is not in the right form. Y needs to be by itself. So this x needs to move over. I'm going to write this to the side. X plus y equals -5. In order to move the x over, since right now it's positive, we are going to subtract. That'll cancel, so it leaves me with y equals -x minus 5. So we're going to use that in place of that second equation. Okay, now second step. Press the y equals button and type the two equations into y1 and y2. Okay, so for y1, this first one, anytime you see a fraction, it's best to put it in parentheses like that. X plus 1. Okay, and then for the second one, we're going to use this right here. -x minus 5. Make sure you're using different buttons for the negative and for the minus. Then press the graph button. So there's our picture. So that means that there's one solution right there where it crosses. Let's figure out what that is. So if you press second, trace, and there's one that says intersection, you could just scoot down until you get there. It'll say first curve. So you want to make sure that your cursor, see if you move it around, is on the first line, which it is. So press enter. Then it'll scoot down to the second line, so press enter again. Then it's going to ask you to guess. You don't have to, so just press again. And now the x and y, that value for the intersection will be given. Here's my x, here's my y. That's the solution. So for this first one, our solution is at -4, -1. So if I were to draw this, it'd be about right there. Something like that, right? So it's not exactly the same, but that's the solution where it crossed. Okay, let's try this one more time so that we can have the practice. but this time I'm going to try to do it without having to look at my steps. Okay, so I know they both need to be in y equals form. Second one is okay, but that first one, we need to fix it. So 5x plus 3y equals 9. I need y to be by itself. So let's move over that 5x by subtracting. Okay, then we're going to divide by 3. So y is equal to negative 5 over 3x plus 3. So this equation, we are going to use it in place of that second one. Or I'm sorry, the first one. Okay, so I know I need to go to y equals. Let's clear out what we have. And let's retype. So that first equation, we're going to use this. Parentheses, negative 5/3 x plus 3. And then for the second one, 1/3 x minus 3. Press graph. There's our new picture. So we want to see where it's crossing. So second, trace, go to the one that says intersect, enter, enter, enter. So there's my intersection, 3, negative 2. That would be my solution. Cool. And now the last thing that we need to cover for this unit is inequalities and what they look like on the graph. So one of the most important thing about inequalities is the shading in. And that shaded region is what we call the solution set. So the solution set of a linear inequality is the shaded region. But if you have a system, that means you're going to have two inequalities. The solution set is going to be the double shaded region. Okay, what about points that would land right on top of the line? Can that be part of the solution set? Well, it depends. So if you have one of these two symbols, less than or greater than, your line, we're going to draw it as dashed. So if it lands on top of that line, no, it's not part of the solution. Not solution. Okay, but if you have one of these two symbols, so less than or equal to, greater than or equal to, so that little underline, it's important that you have that. When we draw it, it's going to be a solid line. And if I have a point on top of that line, yes, it is a solution. Okay, so let's see what these look like. Okay, so for this example, we are given an inequality, 3x minus 4y is less than 12. They want us to circle the points that are in the solution set. So first off, we need to know what this looks like. I need to graph it. But in order to graph it, that y needs to be all by itself, this y here. So let's fix that first. I'm going to work kind of towards the bottom. So let's subtract our 3x. So I'm left with negative 4y is less than negative 3x plus 12. Then I want to divide by negative 4. Just be careful when you divide by a negative, you need to flip that sign. So this is going to become, or let's write it right below. This is going to become y is greater than 3 over 4x minus 3. See how I flipped the symbol? Okay, now we're going to graph this line. So starting with that y-intercept being negative 3, I'm going to put a dot there. Then my slope is 3 over 4, so up 3 over 4. And now that I have two dots, I'm going to connect them. But the symbol that we have here, since it's not underlined, when we do our line, it's going to be a dashed line. So I'm just going to try my best to make this as straight as I can. Like that. Other thing is that it is a greater than symbol. So when we shade it in, we're going to shade the top. So for my picture here, everything that's in the green shaded area is part of the solution. So let's go through those points and see which ones are part of that. So W is at 5, -5. 5, -5, that's down here. That is obviously not a solution. It's in the white part. X is at -2, 3. So -2, 3. Well, that's right in the middle of the green. So yes, this one works. Y is 0, 1. So that's right here. So yes, this one works. And then Z is at 4, 0. So right on top of the line. Does it count as a solution when it's right on top? So for this one, because it's a dashed line, no, it does not. Okay, let's do one more. So this time, it's an entire system. So this time I have two different inequalities that I need to graph. That second one looks okay. Y is already by itself. But this first one, I need to rearrange it to where Y is by itself. Okay, so I'm going to do that here towards the bottom. So Y needs to be by itself. Let's subtract 2x from both sides. And then we're going to divide by 5. So that gives me y is less than -2/5x minus 2. So we're going to use that in place of the first inequality that was given. Okay, so I do want to mention on the calculator, so let's go back to y equals. Let's clear what we have. It only has equal signs. So you can type in the equation. So I'm going to do that. -2/5. And let's type in the other one as well. So x minus 3. But if you go to graph, they're just going to be lines. We don't know what's shaded in. So let me go back to y equals. If you go to this part here, and you press enter, it'll change for us. See how it's going through all those symbols? So what you have to do is know which way it's going to be shaded. So for this first one, the -2/5x, because it's less than, that symbol means less than, that means it's going to be shaded below. So if you look at this picture closely, I'm going to go through them again. See how that's at the bottom? That means it's going to shade it below. Now for the next one, x minus 3. Here's my x minus 3. That one has a greater than or equal to symbol. So greater than means that it's going to get shaded above. So if I press enter, I'm going to look for the one where it's colored above. See that? And now let's go back to our graph. And now it shades it in. But you have to personally know which side is going to get shaded in. That's the only hard part. So I do want to see it on my graph, so I'm going to graph these by hand. Let's do the first one in pink. So it was at -2, -2, and then it's down 2/5, connected by a dashed line. And this one was colored in below. Okay, the next one, I'm going to do this one in blue so we can see it better. So starting at -3, has a slope of +1, and it's less than or equal to. So it's going to be a solid line. And this one is going to get shaded in above because it's greater than. Okay, so our solution set is that double shaded area. It's this part right here. See how it kind of looks purple because the two colors mixed? And if you look at my graph, see that part? It's double shaded. Okay, so let's go through all the points and see which ones match. So J is at -5, -3. So -5, -3. Right in the middle. So yes, that one works. K is at -2, -3. So again, right in the middle, so still works. L is 4, 2, so 4, 2. I know it's in the blue part, But if it's two separate inequalities like this one is, in order to be part of the solution, it needs to be in the double shaded. So that one doesn't count. Nope. And then m is 6, -1 down here. Obviously not because it's in the white. Okay, guys, and that's everything in Unit 4.